Uh, so you are having your exam, like there is a upcoming exam of yours in October, right? Yes, Ifra.
Yes, ma'am.
And Rumaisa, your exam also,
Mom, actually,
right?
my exams have started. So, like next week, we have a math exam.
Okay, you are not having exam in October.
No.
Okay, Sanya ma'am will not take your class. I will take your class just before the exam to clear all your doubts wherever you are having confusion and everything. The extra classes will be taken by me. All right.
Okay, mom.
Yeah. And both of you, please feel free to ask anything wherever you are having doubt, even if I am explaining something. And if you are feeling like it's not getting clear to you, please feel free to ask. Okay. And if both of you want, you can on your camera so that you can also like feel comfortable with me. It's your wish. It's completely up to you. If you want, you can on the camera. If you don't want, let's keep it like this. And if you feel any problem, any confusion whenever I am explaining, you can just unmute yourself and ask. Okay.
Okay, ma'am.
Okay. So here I was telling that in the question it is said, like it is mentioned that we are just having a quadrilateral. Okay. We don't know whether this quadrilateral is a parallelogram or what. Here one more condition is given that these quadrilaterals diagonal are equal. So this diagonal is equals to this diagonal. And one more thing is written over there. And diagonals are equal and bisect each other at right angle. So diagonals are bisecting each other. That means diagonals are cutting each other in two equal parts. So suppose this is the point O and bisecting at right angle. So here we can say it is given already in the theorem that AC is equals to BD. Both the diagonal are same, and it is also given that both the diagonal are bisecting each other. So we can say it is also given that AO is equals to OC and OB is equals to OD. That is given in the theorem already. It's bisecting at right angle. So here we are having right angles. And what we have to show? We have to show that this is a square. We have to show it's a square. Now we will think about the property of square. Like how can we prove that any figure, any quadrilateral is a square? Is that like whenever we are having a square, all the side of the square are of same length. That is the one way to prove that it's a square. But rhombus are also having all sides same. So apart from proving that all sides of this quadrilateral are same, we also need to prove that here each interior angle is of 90 degrees. If we will prove these two cases, then we can say it's a square. What are the two cases? All sides same length. AB is equals to BC is equals to CD is equals to DA. If I can prove that, then it's a square. And also with that, we have to prove that one of the angle, that is angle A or angle D or angle C or angle B, any one of the angle we have to show that it's 90 degree. If we will do that, then yeah, it's short square. Okay. So since we have to prove that all sides are of same length, let's focus on triangle. Here this triangle number 1 and triangle number 2. If we will focus on this two triangle, the opposite one, I'm talking about triangle AOB and triangle DOC. We will be able to prove that these two triangles are congruent triangle. Meaning of congruency means same triangle, exactly same measurement. So if we will show that these two triangles are congruent triangle, then we can say by CPCT, by corresponding part of congruent triangle, side AB will be equals to side CD. And that's what we need to prove, that all sides are of same length. So that means we are going on the right track. So let's prove it. In this two triangle, we can say that AO is equals to AO of the above triangle is equals to OC of the below triangle. That is already given. And we can also say that OB of the top triangle is same as the OD of the bottom triangle, right? That is also given. And we can also say that this 90 degree, this blue angle is 90 degree. Here also this blue angle is 90 degree. Both are exactly same, right? So angle AOB is equals to angle COD. Both 90 degree. Or we can also say both are vertically opposite angle. If 90 degree is not given, then we will use the vertically opposite angle case. Now these two triangles are congruent with each other. Why? Because side, angle, side are same, right? Are you getting it? So we can say triangle AOB is congruent. Congruent means it's exactly same with triangle DOC. And since these two triangles are exactly same, their length, each and every side will be exactly same with each other. Their each and every angle will be exactly same with each other. So from here we can say, therefore, AB will be equals to CD. Is it clear? By CPCT. See, what's the meaning of CPCT? Corresponding part of congruent triangle are equal with each other. If we are showing that two triangles are congruent with each other, then their corresponding parts will be equal with each other. And that's why side AB will be equals to side CD. Is it clear so far?
Yes, ma'am.
Similarly, we will take triangle AOB and triangle AOD, and we will be able to prove that triangle AOB is congruent with triangle AOD. Exactly same way, it's very simple to prove. Like that triangle, one of the side is equals to this triangle, one of the side. You can focus on this one. This triangle, this side is same as this triangle, this side. Apart from that, we are having this common side. Both the triangle are having this side. And also, we can say that this is 90 degree and this is 90 degree. So again, we will be able to prove that these two are congruent with each other. I am talking about triangle number 1 and triangle number 3. Easily, we will be able to prove that these two triangles are also congruent with each other. Now, since they are congruent with each other, their corresponding part will be equals to each other. So from here, we can say, therefore, AB must be equals to AD. Equation 1 and equation 2. Now see carefully equation 1 and equation 2. AB is same as CD. AB is same as AD. So AB, CD, AD all are same with each other, right? It's like Ifra is having 2 chocolate, Rumaisa is having 2 chocolate, I am also having 2 chocolates. So we all three are having same number of chocolates, right?
Yes, ma'am.
So from equation 1 and 2, we can say from 1 and 2, AB, CD, AD, all are equal with each other. And that's what we wanted to prove, that these quadrilaterals, each and every side are equal with each other. Apart from that, we also have to prove that each interior angle is of 90 degree. Then only we can say it's a square. Now also we can't say it's a square, all right? So here, if we will focus on this triangle, this quadrilateral, here we can say that if we will take triangle, this implies that AB is same as CD, is same as AD, is same as BD. We have proved that. Now we will focus on this triangle. See carefully. This triangle. Okay. And the green triangle and this purple triangle. We will focus on this triangle and this triangle. Okay, this one and this one. So the name of the triangles are triangle ADC and triangle BCD. We will be able to prove that these two triangles are congruent with each other. Why? Because all the sides are of same length. So side AD is equals to side BC. Side DC, both the triangle are having side DC as a common side. Can you see? Both of you can see both the triangle are having DC as a common side.
Yes, ma'am.
And diagonal are already given as a same length. So by side congruency rule, we can say this triangle is congruent with this triangle. So if these two triangles are congruent with each other, let's write it. Triangle ADC must be congruent with triangle BCD. If these two triangles are congruent with each other, then this angle will be equals to this angle. Okay. Here angle D will be equals to, let me take yellow color. I am talking about this angle. This yellow angle will be equals to that yellow angle. Okay. So angle ADC will be equals to angle BCD. Why? Because this triangle is same as this triangle. So their corresponding part will be equals to each other. Both of you understand the concept of congruency? Yes or no? Please unmute yourself. Ifra and Rumaisa.
Yes, ma'am.
Yes, ma'am.
Do you know congruency very well?
Yes, ma'am.
Yes, ma'am.
So easily you will be able to prove that these two triangles are congruent to each other. And if these two triangles are congruent with each other, then their corresponding angle, corresponding side, all will be equal with each other. Hence, we are saying this yellow angle will be equals to that yellow angle. Now, we already know that here I am writing. We already know that AD is parallel to BC, because when we have proved all the sides are of equal length, that means it's a parallelogram, right? Only quadrilateral. Which quadrilateral is having this property? All side of, like when all sides are of equal length, only parallelogram can have such property. Okay. Square is a part of a parallelogram. It's a square is one of the type of the parallelogram. Rectangle is one of the type of a parallelogram. Rhombus is one of the type of a parallelogram. So when we are proving this side is same as this side is same as this side, that means it's a parallelogram, right? So we have already proved all the sides are of equal length from equation 1 and 2, the green color part. From there, we can say AD is parallel to BC and CD is transversal. If these two sides are parallel and this is a transversal, can we say there is a interior angle on the same side will be of 180 degree? Can we say this two yellow angle will be of 180 degrees? Are you getting it?
Yes, ma'am.
So we will say that sum of angle D and angle C will be 180 degree because both are interior angle on the same side. Let me wipe it and let me show you properly. We can say if this is parallel to this and here we are having the transversal, then this angle and this angle, if this is x, this is y, x plus y will be of 180 degree. Why? Because these two are co-interior angle or interior angle on the same side, right?
Yes, ma'am.
Rumaisha, are you getting it?
Yes, ma'am.
So we can say that angle C plus angle D is equals to 180 degree. Here we will write co-interior angle. But in equation number 3, we have shown that D angle D is same as angle C. So at the place of C, like we will be writing C plus D is equals to 180. Now either you replace C with D or D with C. So because both are exactly same. So C plus C is equals to 180. From equation 3, we are writing it. Then we can write 2 times angle C is equals to 180. And here we got angle C value is 90. So in the beginning, I have explained that we need to prove that all sides are of same length. We also need to prove that any one angle, any one of the interior angle is of 90 degree. Then and only then we can say this quadrilateral is a square. So we have proved all sides are of equal length. We kept it aside. Now we took two triangle. Okay. We proved congruency that this angle is same as this angle. We kept it aside. Now we use the parallel line concept and co-interior angle, and then we said, but this angle is same as this angle. But the sum of this angle and this angle is 180 degree by co-interior angle. So by using the equation number 3, now we can say angle C is of 90 degree. If you want to replace C by D, you can go ahead and you can show that angle D is of 90 degree. Is it getting clear to you?
Yes,
Please
ma'am.
unmute yourself. Are you getting it?
Yes,
Yes.
ma'am.
And if it is not getting clear to you, and if like you are not telling me also, please make sure that your concept of congruency is clear to you. If that concept is not clear, please let me know. We need to discuss congruency at first before this chapter quadrilateral. Because in this chapter, in each and every problem, I'll be talking about congruency. So if that is not clear, this will not be clear. So please let me know if congruency is crystal clear to you or not. If that is not clear, I will arrange a class on congruency at first. So any one of you wanna tell me that yes, congruency is not clear, not that clear. We want one class on that. Anyone, Ifra or Rumaisha, please don't feel. Just be free. I'm here to like provide the best learning experience to you. So just be free. Yes, Rumaisha, congruency is clear to you.
Yes, ma'am.
Okay, so I'm assuming that congruency is clear to both of you. All right.
Yes, ma'am.
Okay, let's move ahead. This was the whole explanation for question number 5 from the exercise. Let's move to the next question. Now question number 6 says, let me draw the figure, and with the help of figure I am explaining. There is a parallelogram. A, B, C, D. Here we are having, sorry, here angle A, this one is same as this one. So let me read it. Diagonal AC of a parallelogram ABCD bisect angle A. So we are having a parallelogram ABCD. Here diagonal AC is bisecting angle A. As we can see, if this is X, this will be X. Diagonal is bisecting the angle. So cutting the angle A in two equal parts. All right. Show that it bisect angle C also. So we have to prove that this diagonal AC is bisecting angle C also. Okay. So we know ABCD is a parallelogram. So we can say that we know side AB must be parallel to side CD, and side AD must be parallel to side BC, since it's a parallelogram which is already given in the theorem, right?
Yes, ma'am.
Yes, ma'am.
Now we can also say if AB is parallel to CD, both must be equal in length also. AB is equals to CD and AD must be equals to BC, because that's the property of parallelogram. Now we know that CD is parallel to AB. Side CD is parallel to side AB. So can we say angle DCA is equals to angle BAC? I'm talking about this parallel line, the yellow one, this transversal line. Let me take green color. This transversal line. And can we say this green angle will be equals to this green angle? Can we say both are alternate interior angle? So angle DCA is equals to angle BAC. Why? Alternate interior. Right?
Yes, ma'am.
If both are alternate interior angles, so can we say that if this is X, that will also be X? Right?
Yes, ma'am.
If this is X, that will also be X. Right? So let's write it. Alternate interior angle, and if angle BAC is X, let's say, then angle DCA will also be X. Okay. Now again we are going to focus on another set of parallel lines, that is AD is parallel to BC. So we know AD is parallel to BC, right? And this is a transversal line. Can you see the purple line? All the purple lines. AD is parallel to BC. Why? Because it's a parallelogram. And AC is a transversal. So can we say that this purple angle will be equals to this purple angle? Yes, Rumaisha, Ifra?
Yes, ma'am.
Can we say that?
Yes, ma'am.
So we will be writing angle. Here I am writing angle DAC is equals to angle BCA, and both are x only. So this is also we got as x, right? So can you see this x, and then that x also, that x also. And what we needed to prove here, we needed to prove that the diagonal AC is bisecting angle C. So can we say from here that yes, diagonal AC is bisecting angle C. That's why we are getting two parts of C, x and x, right?
Yes, ma'am.
So therefore, diagonal AC is bisecting angle C. Hence proved. We proved the first part. All right. Now the second part of this question says, show that ABCD is a rhombus. Easily you will be able to show that it's a rhombus. Why? Because all the four angles we have proved that are equal with each other. So if we will focus on triangle ADC, just focus on triangle ADC. Can we say it's an isosceles triangle? ADC. Can we say it's an isosceles triangle because two angles are equal? Hence,
Yes,
two
ma'am.
sides will be equal with each other.
Yes,
Yes,
ma'am.
ma'am.
Side AD must be equals to side DC in triangle ADC. Why? Because both the angles are same. So angle opposite, like opposite to this angle, whatever sides will be there, that side will also be equals to each other. And hence, side AD will be equals to side CD. Similarly, if we will focus on the other triangle, that is triangle ABC. Here we can also say that triangle ABC is also an isosceles triangle. Why? Because here also two angles are same and hence two sides will be same, right? So here we can say this implies the side AB must be equals to side BC. All right. It's a parallelogram. Opposite sides are same. This side is equals to this side. This side is equals to this side. And now only we are proving that with the help of isosceles triangle concept, we are proving that AD is equals to DC and AB is equals to BC. AD, DC, AB, BC. Can we say all four are of same length? Because already opposite was same. This was same as this one. This was same as this one. Okay, that was already given in the theorem because it's a parallelogram. Now we are saying that this and this are also same, and we are saying this and this are also same. That means all four are of same length, right? Are you getting that?
Ma'am.
And hence it's a rhombus. So for the second part, we will just take one of the triangle and we'll say it's an isosceles triangle. Hence two sides are same. We will take another triangle. We will say it's an isosceles triangle and two sides will be equal with each other. And hence all the sides are of equal length and therefore the given parallelogram is a rhombus. Is it clear to you?
Yes, ma'am.
Yes, ma'am.
Okay. Let's move to the next one. So here it says we are having a rhombus A, B, C, D. ABCD is a rhombus show that diagonal AC bisect angle A. We have to show that diagonal AC is bisecting angle A as well as angle C. So this diagonal AC in this rhombus is bisecting angle A and C. That we have to show. What is given in the theorem? It's a rhombus. What's the meaning of the rhombus? It's a parallelogram having all four sides are of equal length. That's the property of rhombus. Do you know that?
Yes, ma'am.
So we know that a rhombus has all four sides of equal length, and rhombus is from parallelogram family. So it will also have the property of parallelogram. And we also have to prove here that diagonal BD is bisecting angle B and angle D. So basically we have to prove that diagonal AC is bisecting angle A and angle C, and diagonal BD is bisecting angle B and angle D. Okay, so let's do that. It's a rhombus. So we know AB is equals to BC is equals to CD is equals to AD. All the four sides are of same length, that we already know because it is written in the theorem that it's a rhombus. Now, if we will focus on triangle ABD and triangle BCD, ABD and BCD, look at the triangles closely. Okay, here, just a second. Yeah. Yes, Ifra. Since it's a rhombus, we have taken, it is already given that all the four sides are of same length. We are starting from triangle ABD and BCD. Okay, we will prove that these two triangles are congruent with each other. ABD and BCD. How we will show that? Easily we will be able to show that these two triangles are congruent because this side is same as this side. This side is same as this side. And this is the common side. So side, congruency rule says these two are congruent with each other, right?
Yes, ma'am.
So I am just writing that this triangle is congruent to that triangle. You have to show that it's a congruent by showing that this side is same as that side is same as that side, there is one common side. These things I am leaving on you, all right? It is congruent with triangle BCD. By side, congruent rule, we will be able to prove that. Now, once we will prove that this top triangle and the bottom triangle are congruent with each other, then we can say that angle ABD is equals to, just a second. If we are talking about this triangle and this triangle, okay, if these two are congruent with each other, then we can say angle ADB, this angle, is equals to angle CDB, this angle. Why? Because both are exactly same in shape and size. That's the meaning of congruency. So their corresponding angle will be equals to each other. This two angle will be equal. Now this two angle will be equal. This angle will be equals to this angle. Are you getting it?
Yes, ma'am.
So let's write it. That angle ADB is equals to angle D, not D, C, D, B by again CPCT. Corresponding part of congruent triangle. Similarly, here angle ABD will be equals to angle CBD by CPCT. So we have shown that this red angle is equals to this red angle. And we have also shown that this angle is equals to this angle. Now can we say that diagonal BD is bisecting angle B and D? Can we say?
Yes, ma'am.
Exactly, we can say hence diagonal BD is bisecting angle B and angle D. That's it. Similarly, we will show that diagonal AC is also bisecting angle A and angle C by taking triangle ABC and triangle ADC. If we will prove that this triangle is same as this triangle, then again their corresponding angle will be equal, and then we can say that diagonal AC is bisecting angle A and angle C. So triangle ABC will be congruent with triangle ADC. Now to prove this congruency, I am leaving on you by side angle side, side, angle, you have to check which congruency rule is working over here, and then you have to prove that these two triangles are congruent with each other. Once you will prove that these two triangles are congruent with each other, now we can say that angle BAC must be equals to angle CAD by CPCT, corresponding part of congruent triangle. Similarly, angle BCA is equals to angle ACD, again by CPCT. Hence, AC is working as a bisector of angle A and angle C. I am saying that this angle is equals to this angle, and this angle is equals to this angle. Hence, AC is bisecting angle A and angle C. And that's what we needed to prove here. That you are having a rhombus. Now prove that. BD is bisecting angle B and D. AC is bisecting angle A and C. Is it clear?
Yes, ma'am.
Okay. Let's move to the next one. ABCD is a rectangle. A, B, C, D. It's a rectangle already given in the theorem. Now, in which diagonal AC bisect angle A and angle C. That too is given in the theorem only. All right. Show that ABCD is a square. It is given that ABCD is a rectangle. ABCD is a rectangle, that is already given. And it is also given that AC is bisecting angle A and angle C. We have to show that it's a square. Okay. And there is one more part. We will do that also. So first we have to show it's a square. Now, to prove that any rectangle is a square, what is the property of rectangle? That opposite side are of same length. If this is 5 centimeter, this is 5 centimeter. If this is 3 centimeter, this will be 3 centimeter. That's what the property of rectangle, right? There is a length and breadth, right? Right, Ifra?
Yes, ma'am.
And if we have to prove that it's a square, that means all are of 5 centimeter or all are of 3 centimeter. Then only we can say it's a square, right? So a square means each and every side are of same length. If we can prove that each and every side are of same length, then we can say that it's a square. All right. So here we know it's a rectangle. That means AB is equals to CD. And we also know that AD is equals to BC because these two are property of rectangle. All right. If we will focus on this two triangle, okay, we don't even have to prove the congruency over here because we can say this is X, then this is X. This is Y, then this is Y. All right. Since AB is parallel to CT. Why I am writing parallel? Because rectangle is from parallelogram family. So at first it must have the properties of parallelogram. So AB must be parallel to CT. And also AD must be parallel to BC. These two are the property of parallelogram, and rectangle is a parallelogram. Do you know that rectangle is a parallelogram?
Yes, ma'am.
Okay. So if AB is parallel to CD and AC is transversal, then we can say that angle CAB is equals to angle ACD, alternate interior, right? I'm saying that this angle is equals to this angle, right? Alternate interior. Can we say? Can we say like that?
Yes, ma'am, we can.
Yeah, we can say. So here we got axis same as Y. Similarly, if AD is parallel to BC and AC is transversal, then we can say this is parallel to this and this green line is a transversal. Then we can say this angle, green angle is equals to that green angle. That means we can say angle BCA is equals to angle DAC. Again alternate interior. Here also we got axis same as Y. That means all four are of same measurement. Okay. If this is X, this is X, then this will also be X, this will also be X. All the four angle will be of same measurement. Right? Again, we will focus on two triangles. That is triangle ADC and triangle ABC. Triangle ADC and triangle ABC. And we can say both the triangles are isosceles triangle. Right? ADC. Can we say it's an isosceles?
Can say
Yes, we can say. Because this blue angle are same. So it's an isosceles triangle where opposite side will be of same length. So from here we got AD is same as CD. And if we will prove that ABC is also an isosceles triangle, this angle same. It's an isosceles triangle. So we can say side AB and side BC will be of same length. Now what we know, opposite side are of same length. And by isosceles triangle, we have shown that this side is same as this side. And this side is same as this side. Already opposite were same with each other. Then all the four sides are of same length. Can we say from here? We can say that AB is equals to CD, is equals to BC, is equals to AD. All four sides are of same length because already opposite was equal with each other. Now we are saying this is same as this one. Okay? Are you getting it?
yes.
And we already know this is same as this one. So all four will be same with each other. And hence it's a square. What we wanted to prove, it's a rectangle, and then prove that it's a square. We have proved it, it's a square, just by parallel line concept and alternate interior angle concept. And after that, we have applied the concept of isosceles triangle. Nothing else. Are you getting it?
Yes, ma'am.
We also have to prove here that diagonal BD bisect angle B and angle D. So here we can say that since it's a square, we have already proved in part A that it's a square, hence diagonal BD will bisect angle B and D, because that's the property of a square, that any diagonal of a square bisect its angle. Okay, so diagonal AC will bisect angle A and C. Diagonal BD of any square will must bisect angle B and D. That's the property of a square. Okay, so if we are having a square, and if you will draw a diagonal, this diagonal must bisect this angle, this angle, this angle, and this angle. If you are drawing the another diagonal in a square, another diagonal, then this diagonal also will bisect the angle. This angle will be equals to this angle, and this angle will be equals to this angle. That's the property of a square. So for the second part, we just have to say it's a square, hence both the diagonal will bisect each other. That's it. All right.
Yes, ma'am.
So whatever we have discussed, is that clear to you?
Yes, ma'am.
Just a second. So yeah, rest of the question already we have discussed till question number 8. Yeah, already we have discussed till question number 8. I want you to try from 9, 10, 11, 12. 3, 4 more questions are there in exercise 1. All are based on either this concept or the concept of congruency. Please do practice the question which we have already discussed, and also do practice the rest of the question from the exercise. In the next day, we will be discussing the question in which you are having doubt. Okay, so list down all of your doubt, and we are going to discuss those doubt in the next class. All right?
Yes, ma'am.
Do you want to ask anything from here, whatever we have discussed?
No.
No, ma'am.
Is everything clear, Rumaisha and Ifra?
Yes, ma'am.
Just relax. I'm here to solve your query only, right? You can ask anything. If you are not getting anything, if your concept related to any previous concept like parallel line, whatever I'm saying, congruency, anything you are not getting, please let me know. I'll be more than happy to clear it. All right?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So do practice the questions from this exercise and please finish it. I'll be taking your doubts in the next class. And yes, I'll be taking few more extra classes in future to clear all your doubts. I just want at first you to be comfortable with me. Then only you will be able to ask the doubts, right?
Yes, ma'am.
Yes. So please be comfortable and list down the doubts. We will be discussing that. Okay. So keeping it this much for today.